Okay, hello everybody. Hopefully you're having a good Friday, all that good stuff. Now we're gonna go over mid segments of triangles. Okay, so hopefully it should be a pretty quick lesson. But in short, we're going to go over what a mid segment is, what does it do, its unique property, and then basically how do we use that in our triangles. Basically, how does that help us find missing x's or sides or anything of that nature? Okay, so with that, we're just gonna get moving on in. So if we're looking here, okay, first off, let's just define what the heck a mid-segment is, okay? So a mid-segment is simply a segment whose endpoints, so this blank word here that we need is endpoints, whose endpoints are the midpoint of a triangle, okay? So basically, what we're going to do here is normally if I was in class doing this, you would have a barren triangle with no lines in the middle of it, and we would pretty much grab here, look here, line it up, and you would see, oh, that's 6, oop, that's 3, and we would put a dot there. Okay. Then after we do that, we would have done that 3 separate times on each line and connected them. Okay. Now, the reason why we would do this, then I would ask a probing question here of, hey, those lines, does this line here and this line, does anything stand out? And I would hope you guys would say, yeah, this looks like they're going in the same direction, almost like they're parallel, okay? And if you did think, oh, they look kind of parallel, that's because when you have mid-segments, aka segments whose endpoints are the midpoints of a triangle, the mid-segment is parallel to the sides of the triangle. So this word here would be parallel. Okay. Now, there's a few things that we can mark before I worry about this part here, okay? So if we look here, okay, first and foremost, I already told you this is the middle of this side here, of this line. So what can I say about these two things? Well, I can say that these two things are congruent. Those two segments are congruent. Well, what about here? This is the midpoint as well as this line. Well, once again, these two segments are congruent to each other. But notice, I do not mark these congruent to these two as well. Okay, and then same idea here. Okay, and then as we just talked about, these lines here are going to be parallel to each other. Now, if you don't remember how to do that, friendly reminder, we had these like arrowheads that we would use to show parallel, right? And same idea, same number of arrowheads means that those two lines are parallel. Okay, and then we would do the same thing here. So this one we would put 2 on. And this one we would also put 2 on. Okay. And then from here, we would, lastly, the last one that we need to get done would be this one here. And guys, I'm keeping them off to the sides just so we got some room to work with still. Okay. Now, basically, this is parallel to this, and so on and so forth. Okay. So this line here would be parallel to the line that it does not touch. Okay, just reiterating that. Okay, now once we would do this, as you looked here, this would be about 6, pretty close to it. Okay, so the midpoint would be 3. Well, then I would go over here and measure this line here, and all of a sudden we would notice, oh, wait a minute, this is 3 too. So that means that the length of this line, its mid-segment, is always half of it. Okay, so once again, the length of this line, its mid-segment is always half of it. Okay, so basically what that would show us is from here to here. Let's say this was 6. If I asked you, hey, what number should this be here for this mid-segment, this yellow mid-segment? I would hope you would say Oh, Mr. Bennett, that would be 3, right? So basically, the way we would do that is we would go here, and we would just divide by 2, aka half of it. Okay? So this brings up this idea over here. Basically, and we use this idea, but we actually use it more from the mid-segment out, not from the length into the mid-segment. And what I mean by that is basically, if I multiply this mid-segment, so aka this 3, by 2, should I get 6? Yes. Okay. Like I said, it works both ways. We generally like working with the smaller side or the smaller segment because that allows us to multiply, aka we can avoid this division step here. Okay. So this last little bit that we need to fill in is length of parallel side. Okay, so if I multiply the mid segment, it should be the length of the parallel side. And I have to multiply it by 2 though for that to happen, okay? So, some examples here that I will throw at you, okay? So, let's say I had 4 here. Well, actually, we'll do it here. Let's say I had 4 here. And I asked you, hey, please tell me what this should be. Please tell me what this the side should be using its mid segment. Well, I would hope you would say, oh, Mr. Bennett, its side would be double this. So I would multiply this by 2. So I would turn into 8. Okay, and then so on and so forth. Okay, but truly, we grab the mid segment and we multiply it by 2. If you have the length and you're trying to find the mid segment, we divide by 2. Okay, and then I'll show how this looks like with equations and stuff of that nature. But guys, this is the general gist of it. This is the rest of this is more me showing you situations. Okay, so what I mean by that is these 2 problems down here. Okay, now I will have problems that are going to ask for multiple things. Okay, so basically treat each one as an individual. Okay, now we're going to hold off on x here, and we're actually going to find y and z first, and you're going to see why I'm holding off on x. Okay, so if we look here, z is here, and its parallel line would be that. Okay, so if we look here, if I know my mid segment's 3, well then how would I get z? Well, the way you would find z was you would do 3 times by 2. So z should actually equal 6. Okay, same idea for y, but in reverse. Okay, so if I wanted, I have here, good, those would pair up together. So to get y here, I would basically do 10 divided by 2. Okay, aka y would equal 5. Okay, now this is the tricky one, x. The reason why this is tricky is because sometimes you guys don't realize it. This x is not stretching the full length here. Okay, it's only stretching to the midpoint on that line. Okay, so basically what's going to happen here is there's actually 2 ways to solve this. The one is kind of using this idea. The other one is basically a shortcut, recognizing kind of what's going on here. Okay, so basically the long way would be, well, I know the full length here, and actually I'm going to grab a different pen. I'm going to grab a brown one. The full length here should be double this. So that means this full length would be 4 times 2, which would give me 8. Okay, and then, oh, since this is a midpoint, I know a midpoint is going to be half of this. So that means this 8 should turn back into a 4. Okay, now the reason, so this is kind of the quote-unquote long way of doing this. The quick and fast way would be, hey, You see this here? Well, if this is half of the mid-segment and this here is already half of, well, let me reword that. If this is half of this side and the mid-segment is half of the side, well, that means that these two things must be congruent, actually. So you can just put 4 and 4 there. Like I said, a little bit of a shortcut. Now, this problem here, this is the problem that we use basically this formula up here for, because a lot of these just numbers, you guys just kind of multiply or divide by 2, okay? So the reason why we like working with the mid-segment and going to the length of the parallel side is because it allows us to multiply, aka we're avoiding that division, okay? Now, it does work both ways though, okay? But like I said, it would make more logical sense for us to actually use the basically this way so we can avoid a division with our equations. So if we look here, first and foremost, excuse me, there we go. This line, I hope you guys would recognize the pair up with this, so we're going to set it up here. And we're going to get 3x plus 1 is equal to 10x minus 18. Now, some of the issues that I have on this is people don't know which one to multiply by 2. They just kind of guess sometimes. Guys, it's always the midsegment. It's always the line inside the triangle. So this is the line that we are going to multiply by 2. Okay? So guys, from here, we just go back to our algebra skills. So distribute, we're going to get left with 6x plus 2 is equal to 10x minus 18. Combine like terms, bring them over to both sides. So I'm going to bring this 6x over here and this 18 over here. So if we do that, we're going to get left with 4x is equal to 20. Divide by 4 to both sides, we get left with x is equal to 5. And that would be our answer, okay? Now, if I asked for, hey, find me the mid-segment, the actual length, find me the length of the mid-segment, well, then we would just plug back in, okay? But guys, other than that, it's just a kind of a rinse and repeat, okay? So these bottom ones, I'm going to go through a little bit more quicker, okay? Feel free to pause me, slow me down, rewind me if you need it, okay? So to get going here, x here, I want to find this x here. So the way I'm going to do that is I'm going to grab this mid-segment and either A, I'm going to multiply or divide. In this case, I'm going from the mid-segment to the side that's parallel to. So we are going to multiply by 2 in this case. So this should actually be 16. Okay. Same idea over here. We're going to go from here to the mid-segment. So we're going inside the triangle. And guys, once again, this is where you have to think a little bit logically. Notice, we're going from a smaller to a larger side. So we're multiplying. Well, I'm going from a larger to a smaller side. So most likely, we are going to divide. Okay? So AKA, we're going to divide by 2. So x should equal 22 in this case. Okay? So that's what's going on there. Now, how do we deal with these? Okay, so basically, if we look here, okay, x plus 2 and 4x minus 16. Okay, here we go. So we need to set these up. Now, once again, which one should we multiply by 2? AKA, which one should be multiplied by 2 with parentheses around it? So is it the mid-segment or is it the length of this side here? Well, once again, I would hope you would say the mid-segment. Okay, the mid-segment's always smaller, so that's the one that's always being multiplied. So we would get this here, and guys, we would solve from here. Okay, so distribute the 2, you're going to get 2x plus 4 is equal to 4x minus 16. Then after that, we combine like terms and all that good stuff. So we're going to get left with 2x and 20, and then x is equal to 10. Okay, so that would be our answer for that one. Okay, our next one here, and guys, I'm just changing color so it's a little bit easier to see which one goes with what. Same idea. We would need to multiply this mid-segment by 2 and set it equal to the length of the side that's parallel to. Okay, so we're going to get 2 parentheses 1/2 x plus 3 is equal to 3x minus 10. Okay. Now, this one is the one I really want to focus in on because I think this is not so much the hardest one, but the one that you guys freak out the most on. It's because of this darn fraction here. Okay. Now, we are going to distribute this 2 to everything. Okay. So, to here as well as to there. So, and guys, if you don't remember, when we multiply fractions, top to top, bottom to bottom, right? So, 2 times 1, that's going to give me 2. 1 times 2, that's going to give me 2. X plus 6 is equal to 3x minus 10. Well, guys, 2 over 2, what happens with that? They just cancel out. They cross off. Okay? And guys, once again, if you recognize this, you could have saw this right from the get-go. 2 times 1/2, well, those are the reciprocals of each other, aka they're going to cancel each other out. So, we actually get left with x plus 6 is equal to 3x minus 10. So, once again, we're going to combine like terms, move everything over to the other side, yada, 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 okay? So, we're going to get left with 2x is equal to 16. Divide both sides by 2, we're going to get left with x is equal to 8. Okay? Last but not least, we're kind of jumping back up to here, but once again, just kind of a more involved problem, aka everything's in here, okay? So if we look here, okay, if I wanted to find x, I would hope that you guys would say, hey, x is what? Well, x would be, I have the full length here, so I am going to divide it by 2. So we're going to get left with 18 divided by 2, which would give me 9. So this problem here should equal 9. X should equal 9. Well, what about y? Once again, we're going from a full length to a mid-segment, so we are going to divide by 2 once again, aka we are shrinking. So if we do that, we're going to get left with 8, so y should equal 8. Now, z is the one that normally throws you guys off a little bit, not because I would argue it's hard or anything. It's one of those you guys just start overthinking a little bit, okay? So 17 right here, well, we're going to do 17 divided by 2 once again. Well, if that's the case, we divide by 2. That does not go in nice and neat, okay, guys? And since we don't have decimals right now, we're going to keep it as a fraction. So z is just 17 over 2. And I apologize, it's probably kind of hard to read. Okay, but biggest thing is z is 17 over 2. We just leave it as a fraction. Okay, with that, guys, I hope you're doing well this Friday and all that good stuff. Hopefully this made sense. If you guys got any questions, I'll be back Monday and we can go through them and go over all of that other stuff. But like I said, generally I find you guys do pretty well with this. So other than that, take care, have a great weekend, behave, be safe, all that good things, and I'll see you all on Monday.